move on to anything new, there's some really important concepts that you need to understand that we're just going to go through now from the last two lessons, just to make sure that you understood everything that you learnt by building the circuits in series and parallel. So we're going to start by comparing current in series and parallel circuits. So here is a parallel circuit, but actually at the moment it's essentially a series circuit because I have got this branch is not connected. This is open and therefore there's no current you can see flowing through here. So actually at the moment really this is just a series. So the first statement that we need to look at is the fact that current in a series circuit is the same anywhere in the circuit. So you can see I've got an ammeter here and it's 0.9, and you can see I've got an ammeter here and it's also 0.9. So it doesn't matter where the ammeter is in a series circuit, the current will always be the same. And we're now going to think about, is that true in a parallel circuit? And the answer is no. So if I close this to create, this is now a parallel circuit because we can see the current is flowing through both. You can see that the current on the branches is still 0.9, so they're the same as each other. However, the current over here has gone up to 1.8. So current in series circuits is the same everywhere in the circuit, whereas current in parallel circuits can be different on different branches, and it can be different on the main part of the circuit, okay? What we will want to look at is what happens when we add or take away components in a series circuit. So we've gone back to opening this up so that it is effectively a series circuit. And I'm just going to cut here and I'm going to add in a bulb. So here is an extra bulb. Now you can see immediately that my bulb brightness has decreased and my current has decreased. In fact, it's exactly halved because I'm now sharing the current between two components, and it will be exactly the same if I had two motors or two buzzers or one bulb and a buzzer. We're going to get a decrease in the size of the current because they are sharing the current, and you can see the current is actually moving slower because it's being shared by these two. And if we think about it in the opposite direction, then if we remove a component, we will then increase the current because our component is no longer sharing its current anymore. So it's not sharing the current. So we get an increase. So that's what happens in series. But let's look at now in parallel. So in parallel, if we add a component, so I'm adding a bulb here, but it's on a separate branch. So when I close this, I've now got two bulbs, just like when I had them in series, but they're on separate branches. And you can see that the bulb brightness hasn't decreased. If I open this back up again, look at the bulb brightness here, and then look when I close it, it's still exactly the same as it always was. And that's because the current is the same, it's 0.9. And what happens is the current here is also 0.9, but the current here has doubled. And what that means is this cell is now working twice as hard to push out a faster current here. You can see this current here is faster, but you can see on these branches, where it branches, it's slower. So it's at 0.9 amps speed here. And here it is a faster, larger current. So in parallel, when you add a component, the brightness isn't affected and the current isn't affected on the branches, but it does get bigger overall. And it's the same if I take it away, it doesn't get dimmer or brighter, and the current here isn't affected, but the current on the main part of the circuit is affected, so it's decreased. So in series, we have the state where when we add a component, it will decrease the brightness, decrease the current because they are sharing the current, whereas in parallel, it doesn't cause that to happen because they are not sharing the current. Okay. you should have understood from your last sets of experiments is what happens when we add an extra cell to create a battery. So when we've got 2 cells, we call it a battery, or 3 cells, it would be a battery. And you can see that the brightness has increased on our series circuit, as has the current. So we've had an increase in current and we've had an increase in brightness. In fact, it's double what it was because we've got 2 cells. If we added 3, it would be triple what it was. And this is one of the few examples where if we turn this into a parallel circuit, so here's our parallel circuit, and we look at the current here and the bulb brightness, if we add another cell to create a battery, it's exactly the same as in a series circuit. We get an increase in brightness and we get an increase in current. So both series and parallel both work in the same way when we add cells, i.e. the current and the brightness will increase, and if we take them away it will decrease. So that's the one circumstance where they act in the same way, series and parallel. Is, well, what happens if I add a bulb to a branch, but it's part of a parallel circuit? So let's try adding another bulb here, just in case you didn't understand that part of the experiment. So you can now see that these two act like they're in series, because they're on the same loop here. So the current therefore decreases, as does their bulb brightness. Whereas this one, which is on its own, its current stays at 0.9. And then you add up these two currents to give you the overall current here. Okay, so the main current is, you add up these two here. So here's a little summary of all that. You could pause on here and review it if you still don't feel confident with this information. Okay, on to SC7, which is to build circuits with SPST switches. So don't worry about the fancy name. It's just building circuits with the normal switch that we've been using the whole time. So all you have to do, as ever, is read through the method, then look at the picture of the circuit that you're building. Make sure you take care to look at how many cells / batteries there are. You need to draw in the circuit diagram, and then you can see in this case that you have to predict first what's going to happen as to whether the bulb is going to be on or off. Okay, so you simply need to write on or off in each of these. Okay, and then you have to write in your results and your explanations as to why. So you have to fill in the missing words here. So simply work your way through all of the activities in SC7, building on the website as you go, and making sure you fill all of this in thoroughly, please. So moving on to SC8 Predict, which components will be working. So here we're going to do an exam question that really reviews kind of a lot of the stuff that we've covered so far. And so I'd like you to give it your best shot, and then I would like you to upload it to Shobi so that I can mark it for you, and I will give you some feedback as well. So when you upload your work, please put it in lesson 3 for today. On to SC9 Build and circuits. So this is a bit of a problem-solving task, and it's one which is really difficult. So I'm going to give you a chance to solve this problem on your own, but don't worry if you cannot, because I will go through it afterwards. So here's the problem. An electric grinding wheel, so this is like what you would use to sand in DT with Mrs. Edwards. So an electric grinding wheel must not be operated unless the safety screen is in position. It must therefore only be able to turn on if the screen is down. Create a circuit that uses switches, so more than one switch, to solve this problem. So what you want is, you want for it to only be able to be on if this safety switch is down. So see if you can work out a solution by using a combination of switches, what you're going to want is a circuit with a power source. Just use a battery or a cell, and then you're going to want to have a motor, because this works on a motor, and then you're going to want to have some kind of switches going on. Okay, so have a go at doing just this section here, the solution diagram, using normal circuit symbols. Okay, and if you can't do it, then don't worry, because I'll show you how to do it after this. So pause the video now, have a go at this, and then come back to see the solution. Alright, so I'll just show you the kind of thing I would expect to see as a solution. So I've got my power source. Remember, it would really be the mains electricity, but we're just going to use a cell. And then, importantly, I've got my motor, which is just the nice easy M symbol. And then I've got switch 1 and switch 2, or A and B, doesn't really matter which you called them. So I have got an AND circuit created because I have to turn this one and this one on for it to work. So this one here would be connected to the safety screen, and this one here would be just a normal on-off button that you would find on something. So when that screen comes down, this closes like that, okay? So what type of circuit is this? What do we call this type of circuit? And then once you've filled that in fact, I'll just fill it in, it's an AND circuit. I think that's so easy that we all know that. We're going to then look at something called truth tables. So in a truth table, what you have is you have an input section and an output section. Now the input section looks at the switches you have. So we'll call them switch A and B, or you could call them switch 1 and 2, as I said, it wouldn't really matter. So switch A and switch B. And what you do is you put in all the different combinations that you could have. So you could have this one off and this one off. You could have this one off, but this one on. You could have this one on, but this one off. And you could lastly have this one on and this one on. Now, your job is to fill that in and then fill in whether the motor will be off or on for all 4 of these. And then I'll show you the solution to that once you've had a go at it yourself. So pause the video here, fill in this if you didn't get it right, and then have a go at this. Okay, so let me show you. So if they're both off, the motor will obviously be off. If this one's off but this one's on, it will still be off. Same for if the other way around, because it's an AND circuit, so they both need to be on. So if they're both on is the only time where this grinder will turn on. Okay, so hopefully you have understood all of that, and then we're going to go on to a kind of similar problem in a moment. Okay, so we are now going to go on to SC10, where we're going to problem solve again by building a OR circuit. So your problem this time is an alarm must go off if either the newsagent's door or the back window is opened. Create a circuit that uses switches to solve this problem. So you're again going to try and just do this section here, where you're going to try and create a circuit that's going to solve this problem here using switches. So we need an alarm, so a buzzer, to go off either if the window or the door is opened. Okay, so give it your best shot, and I'll show you how to solve it afterwards if you can't do it. Okay. Okay, so on SC10, let's look at the solution then. So for this one, we want an alarm to go off if either the door or the window is opened. So in this one, the solution is to have a parallel circuit rather than a series circuit. So I'm going to start by drawing out my branches. So I'm going to have a switch that is attached to the window. So I'm just going to label this window switch. And then I'm going to have another switch that is attached to the door, the back door. So I'm going to call this door switch. And then I need to have something that is going to alert me if either of these is closed. So I'm going to have an alarm, so I want a buzzer. So I'm going to do the funny egg cup, the symbol everyone finds the hardest. And it could be over there, but it couldn't be on here or on here, unless you're using two, and then you could have one on here and one on here, okay? But it's easy to just have one. So if we think about it, if I close this, that creates a complete loop here, and this will come on. And if I close this, that creates a complete loop here, and this will come on, okay? So this is, of course, called a OR circuit, because if this one or this one is closed, then that will come on. And again, we'll call it switch A and B. So you are going to try and fill in now. So pause this, get it all up to date, and fill in any of all of this that you can fill in, please. Okay, and then I'll show you what you should have done. Okay, so you should have off, 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 on, off, on. It doesn't matter which order these are in, by the way, obviously. So if they're both off, then the buzzer will be off. If one is on, the buzzer will be on. If this one's on, the buzzer will be on. And if these are both on, the buzzer will be on. So it's kind of like the opposite of the AND circuit, because in most cases it's on rather than most cases it's off, okay? So hopefully you've understood now AND circuits and OR circuits. Okay, so for SC11, you have an exam question again. So I would like you to have a go at the exam question. It's super easy peasy. So pause here and then I will go through the answer. Okay, so looking at the exam question, Sarah connects a new circuit in which two switches control a buzzer. So this is essentially exactly what we've just done in our problem solving for our last activity. So she records whether the switches are open or closed and the action of the buzzer. Complete the table below. So we should have on, oops, yeah, on, off. So when they're both open, it should be off. Complete the following sentence. This kind of table is called and it should be a OR circuit, okay? Not an AND circuit, it's a OR circuit. So really easy peasy exam question there, and you can give yourself the marks if you got them, okay?